I hope you are doing well. Previously in this channel, I have published 2 short videos regarding autoregressive 1 and moving average 1 processes, and I actually derived autocorrelation and a spectrum of those processes. Now I'm going to introduce ARMA with the order of 1 and 1. And ARMA stands for Autoregressive Moving Average Process, and it's a generalization of autoregressive and moving average process. Sometimes we call it pole zero model, and we have more degree of freedom to fit data because we have pole, we have zero. Unlike autoregressive model, in that case we only have pole, and in moving average we only have zeros. But the parameter estimation of this process is quite tricky. Let's go and start and introduce ARMA process. The process is xn equals to a x n minus 1, the autoregressive part, plus e n plus b e n minus 1. This is the moving average part, and this is the autoregressive part, and order refers to this delay 1, and here is 1. We call this process as ARMA 1 and 1 process. How can we deal with this process? I can consider it as a LTI system. Actually, we filter a wide process. En is a wide process, and we filter here. We have a system function hz, and the output is x of n. For finding hz, we only need to take the transform. xz equals to a z inverse xz plus e z plus b z inverse e z. hz equals to output z transform over input z transform, which is 1 minus a z inverse 1 plus b z inverse. The system must be stable, so the pole of the system, a, absolute value of a must be lower than 1. And the wide process, it means the autocorrelation of the process is sigma squared e, the variance of the process, delta function, delta k. The spectrum of output Sx e j omega equals to actually frequency response magnitude squared multiplies by input spectrum. So we have 1 plus b e minus j omega over 1 minus a minus j omega squared sigma to e. This is the spectrum of ARMA 1 and 1 process. Now let's continue and find the autocorrelation function for this process. For finding this, I can use Z transform. We have Sx z equals to h z inverse s e z. Sxz is 1 plus b z inverse 1 minus a z inverse. Hz inverse is 1 plus bz 1 plus 1 minus az, and Sez is sigma squared e. So we have sigma 2e 1 plus b z inverse 1 plus bz over 1 minus a z inverse 1 minus a z. Now for finding the autocorrelation function, I have to take inverse z transform from this, and I use this z transform a power of absolute value k over 1 minus a squared. The transform of this function is 1 minus a z inverse 1 minus a z when absolute value of a lower than 1. But it's a bit different here. We have sigma squared. We can multiply both sides of this relation with sigma 2 squared, but this part I can compute this part 1 plus bz plus bz inverse plus b squared. So I can write it like this. Rxk is sigma squared e over 1 minus a2, and the first term 1 plus b squared 1 plus b squared multiplied by a power of absolute value of k. I put these two terms together, and now z actually causes a time advance in the autocorrelation function. So we will have b a k plus 1, and finally b a k minus 1. Now try to simplify this function. Assume absolute value k greater or equal than 1. I can write it like this. Sigma 2e 1 minus a squared a absolute value k minus 1, and now I write other part. Here is a absolute value k, a minus, so I have to multiply a plus this is absolute value k plus 1, so I have to add a squared, and the last term is b, and finally we have sigma squared E 1 minus A2 A plus 2 A plus AB square plus BA square plus B, and still I can simplify it more. I can write it in the next one plus AB multiply A plus B, A absolute value K minus 1 when absolute value of K greater or equal than 1. The only thing remains is K equals to 0. I have to compute Rx0. Let's go back and put K0 in this relation. We have this term A power of 0 is 1, here is A, here is A. So 1 plus B2, I have sigma squared E 1 minus A2 1 plus B2 plus BA or AB plus AB, which is sigma 2E 1 minus A squared 1 plus 2AB plus B2. If I put B equals to 0, now it's over and I found the autocorrelation function of ARMA process. For 0 lag is this term, K, for K equals to 0, autocorrelation function is this, and for K in equal to 0 is this term. If I put B equals to 0, ARMA change to AR, and as you may see, if you put B equals to 0, the 0 lag is sigma squared over 1 minus A power, and here if we put B 0 A and here A minus 1, actually its multiplication is 1, and we have sigma 2E 1 minus A squared A power of absolute value of K. This is the autocorrelation function of AR1 process. Hopefully you enjoy it and you follow the derivation. If you would like to see more videos like this, please subscribe my channel. Thank you very much.